Hello, my name is Fatih Furkan Erkeç, and today I'm going to make assignment 4, which is practice lab for neural networks for handwritten digit recognition multiclass. In this exercise, we will use a neural network to recognize the handwritten digits 0 to 9. Here's the outline and the package we will use. And here is the relo activation, which is rectified linear unit. And in here we can see linear, sigmoid and relo activation functions. The example from the lecture on the right shows the application of relo. In this example, the derived awareness feature is not binary but has a continuous range of values. The sigmoid is the best on for binary situations. The relo provides a continuous linear relationship. Additionally, it has an off range where the output is 0. The off feature makes the relo a non-linear activation. Why is this needed? This enables multiply units to contribute to the resulting function without interfering. This is examined more in the supporting optional lab. And the softmax function, a multiclass neural network, generates an output. One output is selected as the predicted answer in the output layer. A vector z is generated by a linear function, which is fed into softmax function. The softmax function converts z into a probability distribution as described below. After applying softmax, each output will be between 0 and 1, and outputs will be sum to 1. They can be interpreted as probabilities. And the larger inputs to the softmax will correspond to larger output probabilities. The softmax function can be written as like that, where z equals to wx plus b. The uppercase n is the number of feature categories in the output layer. In exercise 1, we will implement this function by using the numpy. Let's define an az and numpy x z, and define the function a as over numpy numpy sum az. Yes, let's run this solve and let's run this test. All tests are passed, and below vary the values of the z inputs. Note in particular how the exponential in the generator magnifies small difference in the values. Note as well that the output value sum to 1. Let's run that. Yeah, as we can see, we can change the input sets, the softmax and the output layer probabilities. Since they are probabilities, the output is changed between 0.0 to 1.0, and as you can see, the output changes. Neural networks in last week's assignment you we implemented a neural network to do binary classification this week. You will extend that to multiclass classification. This will utilize the softmax activation. Here's our problem statement. We will use a neural network to recognize 10 handwritten digits. And this is a multiclass classification. And the datasets, we will start by loading the datasets. Load data. The dataset contains 5,000 training examples of handwritten digits. Each training example is 20 by 20 pixel grayscale image of the digit. Okay, let's load the data and view the variables. Let's run it. And check the dimensions of the variables. Another way to get familiar with the data is to view its dimensions. We will print shape of x and y to see how many training examples we have in our dataset. In x we have 5,000, in y we have 5,000. And visualizing the data. We will begin by visualizing a subset of the training set. In the cell below, the code randomly selects 64 rows from X, maps each row back to a 20 pixel by 20 pixel grayscale image and display the images together. Let's run this. As we can see, the model representation this has two dense layers with ReLU activations followed by an output layer with a linear activation. This too is ReLU, this is a linear hidden layer, and the output layer is softmax. And let's continue. The layer 1, the shape of W1 is 400 to 400 input, 25 output, and the shape of B1 is 25. The shape of W2 is 25 to 15, and the shape of B2 is 15. Layer 3, the shape of W3 is 15 to 10, and the shape of B is 10. The bias vector B could be represented as 1 minus D and or 1D to the array. Okay. You can see here the model implementation. Softmax placement. Exercise 2, we will use Keras sequential model and dense layer with a ReLU activation construct to 3-layer network as described above. And let's give Keras layers input layer, hundreds, and df keras layers dance 25 activation is relu and name is layer 1 L1 and then for actually let me copy this and this should be 15 again relu with layer 2 and one more linear and L3 with 10 and this is it. Let's try to run this and let's run it. Okay, and let's test the model. Examine the weights shape. The expected output is same as ours. The following code defines a loss function, sparse categorical cross entropy, and indicates the softmax should be included with the loss calculation by adding from logits equals true, defines an optimizer. Let's run it. Okay. And epochs and batches in the compile statement above the number of epochs was set to 100. This specifies that the entire dataset should be applied during the training 100 times during training. You see output describing the progress of training that looks like this. And the loss cost here. And in here, to make a prediction, we use keras below x 2015. This contains an image of 2. The largest prediction index is 2. And okay, let's use this to return an integer representing the predicted target. You want the index of the largest probability. This accomplished by numpy argmax function y y hat equals numpy argmax. Let's compare the predictions versus the tables, the labels for a random sample of 64 digits. This takes a moment to run. Let's run it. Okay. As we can see, this works good, and for now I think I can't see any error here. Yeah, this looks fine. Uh, for not increasing the number of training epochs can eliminate the errors on this dataset. Okay, let's run it. We have 1, 2, 3, 4, 5, 6, 7, 8 errors. Congratulations, we have successfully built and utilized a neural network to do multi-class classification. And this is it for this assignment. Thank you for watching. Have a nice day.